So, stream-driven. The idea was to talk about what we do at Labrodor. Labrodor is a startup. We are only 10 people. Engineering team is now 5, but we've been for about a year just 2. I am the CTO. And I joined the company a year and a half ago. And we found serverless there already, so that's nice. There was a very, very basic MVP. And we started basically building. We started chopping off things that weren't working for us. We basically rewrote everything. And this is a bit the story of our journey, but with a really strong focus on streams. So a quick note about myself. So I've been a consultant for quite a long time. I did the maths doing the slides, say, 20 years of coding. That's a lot. This is the second gig as a CTO, and it's my third startup. When I joined, I had to be honest, I wasn't keen on Dynamo or Node.js. I used the serverless pure Lambda using Terraform in a previous project. But I came with, I did Node maybe 1 year in my career. I'm quite polyglot. And back in the days when I was using Node.js, it was a bit hairy days with, weird problems from one version to the other one. But actually, I started with some Scala and some Java function, and then realized that actually that wasn't really the good fit for the serverless world. And I kind of heard that in this conference as well a couple of times. So do not fear jumping the boat and go Node.js if you're not on the dynamic languages. And Dynamo as well. I heard a lot of stories. Some people super keen. It scales so well. It goes well for everyone. But I have to say that the learning curve, and I'll show you what we were trying to do with Dynamo, was quite weird, quite difficult queries. And there's a lot of stuff you can't do with Dynamo. And then again, streams, I think, might help. But now it's full-on love. So every hour is our primary data source. We store everything there. And we replicate data with streams across different data sources. I think in my career, I always wanted to leverage events. I didn't jump the bandwagon of CQRS or event sourcing. But I was always very intrigued, especially as a consultant, when I joined a few projects where there was this big monolith. And the job was to actually split into different components. And then, for example, there was one project where there was a Rails monolith. And I was trying to convince the people there to use active records on save, on delete, all these callbacks that are available to you. And you can do that as well directly from database. And all this to say that basically, with Dynamo and with serverless, this is so easy to do. While when I was trying to do those sort of monoliths killing missions, it was actually quite hard to convince people to use CQRS because you had to put so much code and so much knowledge into the system. I did try microservices. I did some early works with Fred George. Did many talks around the world around microservices. But I never really liked them. I like the concept. I like the size, the fact that you write it, you trash it away, you rewrite it, you start again. But I also seen big teams working, 10, 15 people building platforms, spending a lot of money on microservices. So again, something I heard yesterday here as well. If you're Netflix, okay, fine, you can do it. But I don't think it's for everyone. Definitely not for someone like a startup pre-revenue like us. So so what do we do at Labrodor? We're basically a startup in the IoT energy space. It's just the tagline. But what we do, we have a device, which for now we didn't build a device. We use a third-party device. And it's basically like a bare minimum Linux box. It does pair with a secure meter, obviously, with a smart meter. This is just a brand, a secure, but there are others. And you might have just electricity, or you might have electricity and gas. And when the pairing is done, these two talk to each other. It basically dumps the data every 10 seconds, and then it flushes over to our cloud systems. So first thing we built was building this dashboard. And you can see basically it's all like geeky data around when you are, what's your consumption with the peaks, and probably guy here was having a shower. This is all real data. And other stuff around, combining kilowatts per hour with cost. And it's not a picture here, but there's also like a 10-second granularity dashboard where you can see really the energy consumption going. Once we built this, it took a couple of months. We also ended up building a workflow, classic workflow to sign up users, obviously. We have a dashboard is a good almost sale tool, but we also need to get user in, so we build this. And again, behind this Dynamo, behind this stream as well, we'll see how. It's again, echoing what people say at the conference, like it's good to have a good dashboard, but you need to do something with it. So if a user has only this dashboard, he can look as much as he likes to the dashboard. After a while, it gets boring. What you actually want to do is actionize. So the ultimate aim of Labrodor is actually switch you to the cheapest tariff. So because we know so well what's your energy consumption, we can also switch you to a cheaper tariff. And in the roadmap, we have also other stuff such as disaggregation, so understanding which device is consuming which energy, or simple alerting. I'm on holidays. There shouldn't be an issue with my fridge. The electricity shouldn't go down, which something happened to me, or this machine is consuming too much. There's something going on. It could be a problem with your system. I divided the slides almost like these are like our Git project. We do like, it's not one Lambda per repo, which is something, maybe I think I have a slide around, maybe is that the right thing to do, but this is basically our ingest phase. So as I was saying, we receive data every 10 seconds from each IoT device. Boom, 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 24/7. We did put firewalls to buffer it. So the API gateway to firewalls is kind of gets for free. And from API gateway, it goes to a data pipeline, and it ends up in Dynamo. I found only recently that some people call this CAP architecture, which is a really nice pattern. They put CAP as something better than Lambda. So an architecture of data streams where you have an immutable list of events as your main data source, and then you copy those events, those data in other data sources, and it's only real time. So this is our ingest phase. So what happens, we have the devices that were in the slide. There are 2 brands. This one is going to get decommissioned. Let's not look at the bottom. And basically, the data comes into an API gateway. We have some code straight on the gateway to actually transform the JSON. This is all HTTPS JSON put. And it goes to firewalls. That gets buffered for, I think 5 minutes, something like that. And then it goes into S3. So this is kind of like sync all there, all the data that we receive from this device. And this runs quite well, quite cheaply. And then is where we started getting excited about DynamoDB and streams. So one thing I always done working with other NoSQL solution, one thing I always repeat myself is always try to store optimizing for reads. So saving, especially in a case like this where you don't care really about the result of the save, you just dump stuff. But you need to dump in a way that then you will build an API at some point, and it's easy to retrieve. Now, the amount of data is actually quite large. If we look at this 10-second data, you have a decent set of, in a graph. Imagine the web UI I was showing before. It's pulling data for the 10-second disaggregation. It's pulling the yearly data, the monthly data, the daily data. So there's actually quite a lot of API calls going on. And what we build it is in this way that in Dynamo, it will be just a key value. In fact, when I was trying to code this, and I still didn't know anything about serverless as much as I do right now, a year after at least, I was actually thinking about Redis for this specific problem. And I said, I need to go to a VPC for this. Let's not go there. And then we scratch our head around Dynamo, and we end up using that. So this sort of cascade of stream, of table and stream and table is basically based on a function. And it's actually, putting it this way is actually quite simple after all. So basically, you have the 10-second data, and that 10-second data will have a timestamp. And then all you need to do is basically format that 10-second data in, 5 minutes, which is our second bucket, and write a series of data inside Dynamo to explain that in those 5 minutes, you get all of these 10-second data. Then you go to the next level, 30 minutes. I think we do, for example, apply a min and max only. So we know at 0, 0 the hour, what is the energy, and what is at 0, 30. So an array of 2, and so on. So the algorithm keeps going, and the code is very concise. In this, I don't know if it gets it clear. I think it's easier to read the code than showing this other stuff. So before, we were talking about ingesting data that ends up in S3 as raw. Obviously, there are events. So every time a record gets into S3, there is our first 10-second process that reads the JSON. Actually, at that point, is CSV. And then, basically, this Lambda listen to the Dynamo stream of this event and say, oh, a new record got inserted. All right, so let me figure out in which key I need to insert the same data here. And then when this is inserted here, it keeps going and say, oh, I'm on the function for 5 minutes, so I'm going to insert in a different way in a different table. Oh, I'm the 5, and so on, and so on, and so on. So that seems to work quite well and is reasonably cheap for us. And I think the UI is really fast. Of course, the UI is, again, API gateway reading with the Lambda from Dynamo. So this got us really into kind of like querying, doing some powerful queries for avoiding duplication as well, because we get a lot of duplicate data into Dynamo. And Dynamo get de-dupes for us for free. And also, you don't pay for it, because if you don't save, you don't save. It's not a right. But what are the lessons learned? So yeah, we do immutable saves, which I like, and we try to do across other parts of the domain as well. Probably, if I will go back, I will try to actually go for an immutable database, a purely immutable database, because someone somehow can always go there and change those records. I would really like to have a record that is not deletable and not updatable. At that point, I'm more confident I can replay over and over the data and slice in a different way. And the big learning for me, because this is my first IoT project, and the way people describe it is actually aggregating at edge. So it is very, very silly and kind of very, very wrong, and we'll have to address this next year, to send an HTTP request every 10 seconds like that. So if you look at the numbers, that's basically the 8,000,064 requests in a day, 24 hours. If you have 1,000 users, which would be quite a nice place to be for us to have 1,000 users collected. But then you got to crazy numbers like this, 8.6 billion. If you have 1 million users, which I would love to reach 1 million users, it's not even talking, it's talking about like a sixth of the UK household that have a meter. So what IoT done right? So the first step, I think, of doing IoT right will be to use MQTT, which is also really easy to use with Amazon. And the second thing is aggregating at edge. So those calculations, those sort of map reduce that we're doing with Dynamo, you probably want to do it at that source. So the Linux box may be a little more powerful, and either you send something like I have 3 kilowatts per hour for the next hour, or for the last hour, or you actually send more complex structure where you send already series and zip and try to compress stuff. Because like this is basically, apart from the API gateway will take it, but it's actually get too expensive. And I know, though, that there are systems that actually build like this and are live with a lot of UK customers, and they pay about $1 million a month in AWS cost, which it's a bit of a lost game. All right, so got excited about this, and then what's the next thing we got excited was obviously the business now has a dashboard, so the user can register. They can see their energy consumption, but the business has always a lot of fair questions around, okay, how many users do we have? And now, if you put the users into Dynamo to know that answer, you need to do a recursive scan, which is also expensive. And then it gets more and more tricky. Okay, how many completed users? How many users with a device? How many users with a device which has this sort of type of meter? Now, Dynamo is not really meant for doing those queries. So the very first iteration of LabCRM stream was to save into MySQL with some really rough code that basically took a JSON object from Dynamo and saved it to a MySQL database. And I was using, I think it was called Redash, to kind of do some graphs. It didn't last long. And then like we said, okay, let's use Elasticsearch. So it's built for search, and at the same time we needed an internal user management system called CRM. But basically, the operation team, which is now only for 5 people, wanted obviously to search by anything to find a user, or search by a type of meter, search by energy provider the user might be. So completely search on our Dynamo database across different tables. And the business wanted some dashboards and some queries. So the way it looks like right now, I don't know how many tables we are in Dynamo, maybe 15 now. It's quite decoupled, but basically it's one-to-one. So let's say the user table, or we have, when we store our emails table, they all have a stream. They all have a Lambda that's triggered when something gets changed or inserted in those tables. And then what they do is they run some code, and they basically save into Elasticsearch. Now, in order to answer sort of join questions as well, we just don't do one-on-ones, but there's also some code that does basically pre-aggregation. So whenever something changes inside the user and some relative tables, the data gets put all together and saved into the same index. So that enables us, to do kind of join style stuff. That's the UI. Fair point from the conversation before. I mean, we are, I would say, 99% serverless as a company. There's a couple of places where we had to build some third-party integration, and we have a couple of EC2 instances that pretend to be servers, but they are actually backed by S3. And for the front end as well, we use React, and we do CloudFront and S3. And this is our managed UI. That's what the operator sits, the developer environment. And they can really search by anything, or all of these sort of filters are actually, this is inside the user, this is inside the meter table, this is inside the issue table, this is inside the switch table, but it all gets together inside Elasticsearch in one big document. And you can paginate and all sort of stuff, which in Dynamo is not really built for it. So on this one, what did we learn? So one-on-one is really easy, and I think it's already quite powerful to actually get a collection of documents that are searchable. I remember a conversation with one of the guys that built Elasticsearch, because I was having a bit of a rant on GitHub on an issue that I couldn't find some documents, and he was saying Elasticsearch is not a database; it's a search engine. So it's actually quite nice to be able to use the right tools for the right job. So we have Dynamo, highly consistent for our source data, and then when we want to search, when we want to aggregate, want to do something else, we can use Elasticsearch. I quite like that. Aggregating actually is hard, and there is still, like as I said before, kind of number 1 for 2019 rewrite. There is some code that I'm still not happy with, and there are still kind of errors. Because the issue is in a serverless world, in a very asynchronous world, if say you have 10 tables and those events will arrive at any given time, and then you have cold starts or some function more warmer than others, basically you will never know which function will trigger the rebuild of the compound object where everything is. So that is still something we need to figure out, to be honest. And there's different ideas. We can use Kinesis, so we can probably have an event log and streamline a little bit better all our events. And then at that point we'll have more. I think it should be easier. The other idea is maybe try to do a first aggregation already in DynamoDB, just because we know it inside out a bit better, and it would be much more less prone to version error, especially. Or another thing that we actually already have in place is just leave it. Another pattern is to use EMR and Athena. We're running only one query right now with this with this pattern. So it's basically no streams at all. Basically, the idea is you have the Dynamo tables, and you can configure actually an EMR Elastic MapReduce cluster to actually put together the tables, and then have the data available in Athena for queries. And in Athena, you can do old school joins and stuff like that. I just don't like it because we try so hard for like a year and a half to be real time, pre-aggregated, that doing this seems to actually defeat the whole goal. But maybe we're trying to push it too hard for the pre-aggregation. And then there's kind of like more standard stuff. I think if you go on the Amazon page on Dynamo Streams, they actually talk about the example where a user registered, and yes, all these fields are complete in your schema for what your schema definition is, and you send them an email. So a user status, we have like 4 or 5 user status changes, and obviously we send different emails, different UI. We show different UI depending on what the user status is. So there is a lot of sort of reactive code to deal with the change of the shape of the data inside the tables. Another thing that might change is the switch. I mean, I was new before joining this company, but the switching of energy is actually quite a complex process with 10, 15 different statuses, rejections, partial rejection, and all sort of things. So again, depending on what we get from the third parties, we actually react on those events. And it could be that we create some tasks for the operation team to deal with, some tasks for the DevOps team to deal with, or something for the user. Hey, look, great, your switch went through, and it's fine. And then we have a lot of third-party integrations. And again, I think it's a bit of the energy world, apart from newcomers, is quite an ancient world. So often we deal with stuff like file on SFTP and stuff like that, and they keep changing, informing us, but in a very asynchronous, very, very late, sort of old school way. And again, that I think the stream helped us to figure it out. Very, very vague diagram. There's a reason. I will explain in a minute. So let's say then again, various Dynamo tables. And then we have the Lambda that handles the user changes, but there's also switch changes. And then maybe we save somewhere else, so we do some other actions depending on the data change. I intentionally put various DDB table because it's almost hard. So this is one of the drawbacks, I think. I was trying to actually like maybe draw a diagram for this conference, or try to list them all, and I just give up. Okay, there's no point. This is one area where again, I think as a team we need to work towards, because it gets really hard. Who tells me, like, there was a couple of weeks ago we built like yet another Lambda, and are we actually saving in the same table? Well, the stream is, because you will end up in a loop. So I think there is need for visualization, and again, that goes probably into the observability sort of trend, and we need to actually visualize a bit better what is actually going on, what's the flow, especially with the team probably will double size again next year. Or maybe we can use different techniques, and we started using SQS, for example. All right, another one. So yeah, not everything can be real time, because basically third-party work, sometimes we have some jobs that run weekly or sometimes run daily. We have special requirements of companies, like, you can send us data on a Monday morning between 9 and 10. Okay, yeah, we can work on that. We did that. It is a little bit of a sort of MapReduce. So let's say you have 1,000 users that register on your system. What we do is we collect those users for that week, and we publish to Dynamo. It says like, okay, on Monday, these are the users you need to send to that third party in order to be processed. So this helps a lot with those sort of strange requirement around timely batched event, I suppose. So then again, yeah, so we do basically have a table for our cron jobs. And things go here again is mostly event. A user registered, a user switch, a user had a new smart meter installed. We need to react to the event, write to the cron job, hey, next Monday, can you check this for me? And the cron lambda is just as really like a cron lambda as you will do in serverless. So yeah, he has a time and a date, a cron expression really. And you will run and collect all this data for that day, push it over to the third party. So this was actually quite a success case, I suppose. I'm very, very happy with it. There is also something that we do here is de-duping execution. So one thing, actually no one mentioned the last day and a half, I think, and not least of the other talks I went, is like, yeah, sometimes serverless, sometimes Lambda can execute twice. We had this problem, which didn't have time really to investigate more, but one of the third party was putting a file on a SFTP server, which is backed by S3, and we received the event twice. So of course you can build your system to be completely, I forgot the word now, but it was when a function applies twice, the result is the same. But yeah, the other option is actually, no, I just put into Dynamo the event that happened, and then I will fetch when I'm sure that actually it's safe to fetch the data back again. The overuse is a bit of a problem. Again, with team growing, and because of the name, the temptation is the one to write a lot of cron jobs that go and do scans or do big queries or stuff like that. We want, again, pre-aggregate and use streams. We use this as well for Trello, for example. We archive all the done cards in Trello, send an email to management, so they have like sort of like weekly release backlog. One new, probably latest sort of integration pattern that we did was SQS jobs. So as I was saying before, everything was kind of like a graph of decentralization. Who's calling who? I don't even know anymore. But this one is actually centralizing something that we were doing in a lot of places. We have two things we do a lot. One is sending something to the user, so it's an email. We have quite a lot of custom emails that we send to the users. And the other one is issues. So an issue is basically like some sort of tag for the user that the operation team will have to look at. And there are categories, subcategories. And we're doing that all over the place, all over the code. Option 1 was to extract the library, didn't want to do that. Option 2 was to use SQS. So let's say we want to send an email, even like congratulations for registering, or did you forget to write your own bank details? And we basically put in a queue that we're going to send an email, and then we have only one email dispatcher lambda that actually reads the queue and then puts it on an email queue, effectively. So still a big work in progress on this one, I guess, but we basically managed at least to put all the handling of emails, all the handling of issues in one single central place. And a nice side effect is because there's so many emails, actually we built, this is a nice little internal web app where the code that does the email templating is actually served on S3. So we can actually see what are all our emails offline without having to send them. So it works as a two-side job. There's still things that we need to understand and learn from SQS. For example, when you have an error in the Lambda that is consuming the SQS messages, they are in flight and you can't do anything about it. You can't see what was wrong with the messages. So this goes a lot into, again, traceability and having who sent this message to SQS, from where, and having kind of like a dead queue letter sort of scenarios where you can recover. We tried a lot to not also have writing shared libraries. I don't believe in that because obviously I'd rather have copy and paste code, because if you're trying to build quite isolated Lambda functions and then you have NPM libraries or similar stuff going all over the project, then you're building another monolith. But for this specific case, I think it's time to actually have something that defines properly the message and defines how a message looks like inside Labrodor. And we are trying to investigate a bit instead of NPM or NPM.js or Artifactory for actually having local dependencies that get pushed in different projects. So, all right, cool. So quickly a bit of code as well. So we use serverless across the whole architecture, but for the stuff that serverless doesn't help, we use Terraform. We find very happy with that as well. This is very simple. That's all you need to do for like a Terraform table definition without the stream will be without these two fields. And you can get you can tell what comes out from the stream. So you can tell just only the keys, the new image, the old image, or the new old images. So it means the old object before I was saving, and the old one. So you can actually say from A to B. How did I go from A to B? Which I find quite nice. The handler, again, we use serverless YAML all over the place. This is the YAML file. You can also decide where you start reading. So trim horizon, latest. So it's at the beginning or at the end of the records of the record of stream that get changed. How big is the batch size? And you can also say a timestamp if you're using Kinesis. Now I put this here because it's basically a pointer to this. I put this here because basically this is one of the annoying things. Like one of the things you do in stream in Dynamo, you can only once you create it will write a timestamp, and that's the idea of the stream. That's the only annoying thing, because basically you need to create the table first in Terraform, and then go back. If something happens, you need to recreate. You have to go through your lambdas, change the user stream ID. But that's what we got. I think it's still a minor cons. And the code Node.js really simple. So you will get basically an array of records inside the events, and you will also have the event name, which is basically remove basically CRUD operations, and you can get the image. Assuming that this is using new image, you will get it as you get it on Dynamo object. So it's the same format. Couple of notes from AWS docs. So they recommend to not have more than two processes reading at the same stream at the same shard. Obviously, you're doing a read. When you do a stream, obviously you're pushing out documents, so it's like having a read. So let's say your table already has read capacity. You're actually adding some more capacity, consume more read capacity down the bottom like that. And this one, I love it. It's 24 hours lifetime only. You have to fix it. So what happens is if you have an event on a stream and the Lambda has an error, you got 24 hours to fix it. So that goes again into you build it, you run it, you fix it. There's no, if you break something on a Friday afternoon, we love to push code on a Friday afternoon. You'll have to fix it on a Saturday. There's no way out. We use IO pipe as well. So this is ours. I think I don't remember if I filter. Yeah, I must have filter, no filter. So it's all the function we have is 253. So we didn't build one function a day, but let's say also it's dev and prod environment. So we couldn't have done it without stuff like IO pipe. Obviously, we will not know when something doesn't go well. Further last consideration before Q&A. So I think when it's too generalized, when I was describing before, one of the few lambdas that do that is actually hard to keep track of it. I can see that in a while it's going to be hard to do team onboarding and explain all what's going on. It becomes very complex. Too centralized, it gets a little bit a monolith. So everything then is there. Then you're doing event sourcing, but everything is in one place. It becomes your bottleneck. And the other thing is definitely that complex architectures that in the previous year people tried and spent a lot of money and time. Yeah, this was easy. Most of the code we wrote to implement this was two and a half guys for like less than a year. So it's really easy. That was it.